I want to design a cheap, easy-to-use multi-rotor to aid in the search and rescue of victims in disasters. This is what I came up with. This is a design of what it might end up looking like. As you can see, it looks very compact and much like a racer quad. I tried to do this in order to be able to achieve maximum flight capabilities in a super tight space. It also keeps a lot of the price down. Now, you might see that all of my ESCs and the props in this are probably like racer quality. The size of a racer, a 250 size, would be able to give it enough size to walk by a branch, go through or under some debris, and also be able to achieve decent flight times. These are other type of configurations that you might want to do in the body. This is very different because it's a 450 size quad. Now, after a lot of research and a lot of investigation, I managed to cut it down to 4 basic things that the quad needs. FPV or first person view, telemetry, GPS and OSD, which stands for on-screen display as you might see in my glossary, and a very good range. Now, let's start with FPV. What will FPV do? FPV will enable the user to go to unseen places, which will allow it to see what the multicopter is seeing. FPV is basically a camera that transmits live video from the front of the quad onto a goggles or a monitor that the pilot is seeing, which allows it not to have point of view, which would be like I can see it right there flying, but rather to be able to fly it out of sight. Yeah, still in range though. Now, this allows for flight outside the user's view, which extends its range and its versatility. Because not only you want a search and rescue quad that's easy to use, but that's versatile and you can use for other things. And since we're going to be transmitting this video to the goggles, you will reduce the distraction when you're on the field, so if something passes by you won't miss it because you won't see it. You're totally covered by these goggles. This is what the goggles look like. In there's a pair of screens, which you can clearly see, even in bright sunshine, and the battery lasts for about 3 or 4 flights. This is what a user might be seeing. This is a picture taken by me in my condominium, in my house. So you can see that it's not full HD video, but you can clearly recognize the person that's doing the yard in one of my neighbor's lawns. Now onto telemetry. What is telemetry? Telemetry is basically the information transmitted directly from your quad that will let you know if there are any problems in air. So it shows the performance that the quad is giving while on the air. So this first shows battery voltage, and battery voltage, when you're talking about lithium-ion batteries, is basically battery life. So you can calculate from this how much battery you've got. So you can estimate the battery discharge and estimate a flight time. Now, performance while in the air. If you feel that the quad is asking for too much throttle, or it's kind of shaking a little bit and you cannot control it well, you can look down at your telemetry, which in this case would be on the on-screen display, and it will tell you, oh yes, there's this, or one motor of yours is not giving enough kV, so it's turning really fast. Yeah. And it also enables for in-flight troubleshooting, which is what I mentioned before. If your main board stops responding one of the motors and you just start spinning, and you think you've killed the motor, you can just look down at your on-screen display, and if the motor is not spinning on the on-screen display, it's because the motherboard didn't tell it to do it. Now, that's what the transmitter would look like. And right down here we would have a telemetry view, and in this case we will have a telemetry view on the goggles. Now you can see right over in these spots, these are the 2 joysticks. In this case this would be throttle because it's a mode 2, and this would be the Yeah. Roll, pitch. This is yaw and throttle. Now for the range, the last part. We need 1.5 kilometers in average. Now, why would we achieve 1.5 kilometers average? Or, like, that's the minimum. We will utilize open frequencies. So there's 2.4 gigahertz, which is a really low open frequency, which is really good. Because when the waves are really big, yeah, they're able to go past objects. So for example, I've got my phone here, and let's say you have a really small wave. So we have 8.1 gigahertz. That one will go like this, a crash, and just stop here and maybe go through, but maybe end up here. Now 2.4 gigahertz is really big, like meters in altitude. So it will go like this. Miss my phone, yeah, in every direction. So that it's really good when you're flying behind trees, around houses. Still doesn't mean that you can go like behind a building, but it will give you really good range. And 5.8 gigahertz is a really common frequency for video, and it's really cheap. That's the important part. It's a really small frequency, but it's really fast. It's the only one in which you get zero lag, zero latency. You get about like half a millisecond to a millisecond max in latency. And you don't need ham license from any of those. People might say you need a ham license for 2.4 because a ham license is something that you need for lower frequencies, yeah? But 2.4 is an open frequency. You can use it for whatever you want. And here in Colombia, for example, which we have really nice fields, there's no need, like, there's no closed frequencies, only like ham license style. So the range will maximize the area on a mission, and it will permit more grounds to be scanned. Yeah, this will allow for the quadcopter to go farther, find more people in farther places. Okay, so this is what I told you. If this is an object right here, so I'm going to draw the object. If this is an object, this wave would kill it. Now, when you're coming onto a smaller wave, it'd be something like this. Yeah, won't go through. Same size of object there. Let's suppose this is a 5.8 gigahertz antenna. It's circularly polarized because with this little wavelengths at 5.8 gigahertz, they're about this big. Yeah, they're about this big, so you don't need a very big antenna. It's something like about an inch across. So when the circular polarized, that means that you don't need to have two straight poles in which, like this antenna's right here, because in those you get maximum range out of the sides of the antenna, but on the top and the bottom you don't get much. And also if you go like this with one of the antennas, this antenna will start losing range because it's not same polarization as this one, as the other one, yeah? With the circularly polarized antennas, you can have one like this and the other one like this, and then you can turn them around all of you want, and they transmit the same amount of waves in every single direction, in every single angle. Yeah? So if you want to go really technical, you can just look at the wiki on the our multicopter thread in Reddit, and they'll tell you a lot about frequencies. And now finally the GPS and on-screen display. This is deadly, yeah. If you don't have this, you basically don't have a rescue quad. So this will overlay the telemetry on the FPV downlink. This will enable the user to read out the important values without removing your goggles, yeah? So if you want to check a motor or if you want to check battery voltage, you don't have to go like this. You just go like this, and you see it on your goggles. Also, it will allow the user to know its exact coordinates using the on-screen display to display them, and the GPS to actually transmit them. So it will enable the user to be able to actually locate the victim and send someone to rescue that victim. So if I'm flying here and right over there, I see a person, I cannot tell the rescue guy, like, yo, under the third table, on the dining room, in the red house. Yeah, they don't act that way. You have to tell them they're on 5.828 west, 3.32507 north, and there they'll be. And if you know your battery voltage, you can basically know your flight time. Yeah? So you don't want to be 3 kilometers out and have a minute flight time. That won't happen. Yeah? So this will overlay your battery voltage. Now I'm going to show you a picture of what it might look like. Yeah? You can see right on the top left corner, we can see very nice coordinates, yeah? So, and now in the middle you can have your RSSI. This one won't work on the real quad, but that basically gives you signal strength. It's really complicated to read RSSI values because it's very, very, very dependent on polarization and wavelength strength. On top you have the time of the day, which is gotten by FPV, like the GPS will tell where it is and then it can estimate the time zone. Now you can have a fixed altitude, which you can do, and also a normal altitude value, which is important for flying at night. If you know that the tallest tree is 30 meters, you want to be flying 40, so that's important. On the bottom, this clock that's on zeros, that will be a timer, an in-flight timer, which is really helpful mixed with the battery voltage, which is on the other side, or 2 batteries actually, if you want to put 2 batteries in this thing, which can give you really, really good, really, really narrowed down flight times. And of course your speed, you won't be using that for nothing. If you want to screen cap this is basically the most important part. That's like a really, really cut down, like straight on to the point mind map of what we need. Now for the parts, which is the actual part of the design, this would be on a link and several screen caps. You can get all of these from Hobby King, yeah, and you can see, you know, I'm including a LiPo charger right here, transmitter, goggles with the camera, and every single nuts, pieces, or antenna mounts that you need. Also, the flight controller is a soldered pin version, so you don't have to learn how to solder. So every single little bit that you need to actually control this is in here. And we are actually including 2 sets of props. So there's 8 props in each one, which gives you enough for 2 sets. Yeah, you have like 4 sets of props. So you have this 2, which are really breakaway and give you really nice thrust, and this bull nose, which are really, like, really hard. Because one of my goals at the beginning, like personal goals with this, was to make the drone really, really versatile. Yeah? So by meaning versatility is, it's a 250 race board. Yeah? I can unlock race mode on the actual board. Yeah? I can totally do that, and I can race this little quad. But if the moment appears which I need to rescue someone, I can totally use it. Also, I want to take some pictures. Well, I'll strap a GoPro under. I just put a anti-vibration mat. That's it. So it's a really, really versatile quad. Plus, it's open for beginners to open it up, so since it's really cheap and you're a beginner, you might want to get this. So it's $698.34 US dollars, which gives you the transmitter and the goggles. But if you're already a hobbyist, chances are you already have a transmitter and some goggles, so that's gonna end up costing $298. That's just the flying machine, because the goggles and the transmitter are $400, not each, both. Now, really technical specs. Size is the 250 size, which means it's 25 centimeters from the middle of the motor on the bottom, the top of the opposite corner. Now the tow, or the takeoff weight, is 823 grams. That's the amount of weight it can just lift off and just fly up. And the thrust we're having is 280 grams. 2080 grams, which gives us about double takeoff weight, which gives for a payload. So if you want to strap on like energy bars and things to send out, you can like evolve this project onto something that can deliver things. Yeah. Now the thrust ratio, that's really important if you want to know how much your throttle will be doing for when you're fixing your PIDs as a racer. That's 2.527, and the battery estimate times, and I have to give the milliamperes, using a 330 milliamperes, 3300 milliamperes battery, 3 cells. That's the stun deck right here. We're giving 21 to 32 minutes in flight, and the maximum range of the 2.4 gigahertz, it's 2.5 kilometers, and then it will initiate a flight failsafe, which using the GPS it will start going back to home. So right when you regain control, it will tell you, and then you can disable the back to home feature. And on the video it's 2.23, so you're really never gonna have remote issues because we're using a bigger wavelength with a bigger range, so the interference will all be shown in your goggles. Plus, flying far, really spotty video. Now the charge time for the batteries, many people will ask me these, is 2.5 hours at safe voltage, yeah? Just no explosions, nothing. And the minimum charge time is 1 hour. But we're using lipos here, so it might explode. Excuse me. So I really hope you enjoyed.